And that is, I do want you all to be, this is one of the big reasons why we want to be on Perforce as soon as possible. If you haven't already taken the time to kind of get your Perforce account up and running, you want to be sure of that. So, like I can see, let's see, here's everybody's account here. And the idea is that I will be able to pull down everybody's projects directly through here. And there's also, hopefully you're able to see an AM and PM section here. And that is where I'm going to be eventually, well, I'm not on the VPN because it does slow down my connection sometimes. So AM and PM, occasionally I'll be putting code snippets there that are designed to kind of help you out with the projects. Now, the reason there's an AM and a PM section and you're going to have access to both of them is because sometimes we're going to be posting the AM recorded lecture as necessary, or the PM recorded lecture as necessary. So I want to have the code that went along with each of those particular classes, potentially. All right, so there might be different variations. There might be an AM project and a PM project. And you're certainly, it's fine to look at either of them. Sometimes it'll be an actual project. Sometimes it'll be a code library. Sometimes it might be a package, that sort of thing. So I'm going to keep an eye out for that. I'm going to need to do another tutorial on how to actually pull a package out of Perforce. So it's not something you are expected to know at this moment. So for the first one, I may actually even just post some files on Discord that you're going to use to open up the project that with the sample code in it. So don't worry about that, but do check in, make sure you're able to get your user directory, follow through the tutorial, get that up and running. So we'll close P4V in the meantime, get that out of the way. Shrink it down. And the enticement here is, for example, and I guess I have my video up here as well. In a minute, I'll turn off my video just so I don't wind up obscuring the screen. Hold on 1 second here. Let's see. There we go. Now I'm out of the way. So here's a little sample program, and the idea here, I had this is kind of a late breaking idea, and I'm really excited about it because it's sort of a two-for-one here, where we can look at programming and general syntax and so on, and play with that in the actual sandbox, kind of test bed of the game itself. Now, what do I mean by that? Well, you'll notice over here we have what looks like sort of a little calculator, right? Kind of like a calculator. It's not entirely complete yet. It certainly is more complete than this morning's version, so you all win in that regard. That will look at a little bit more complete version of it. But let me pull this open here, and you'll see we have this little calculatory looking thing. And what I can do in here is I could say, well, 1, you'll see this text up here, 1 plus 1 equals 2. And I could say plus 9 equals 11. And I can say minus 1 equals 10. I can even say times 2 equals 20. So some basic operations. And I can even go so far as to say times 10 equals 200. So it even counts you're able to do multiples of 10, right? That's exciting. This is kind of a little different than this morning. We stopped a little bit short. You're seeing a more completed version. We'll look at the code for that. And this is all driven from the Unity interface. All right, these are all UI elements. The text up here is just a simple Text Mesh Pro text box. Right? These are all buttons. We have a Text Mesh Pro text box. You might think that there's a lot of code behind here, and this is the other reason to kind of show it to you this way is to sort of set you a little bit at ease in terms of the amount of code you need to write versus the amount of functionality you kind of wind up with. All right, so we're looking at this and multiplication, all this kind of great stuff. This is all driven by a single script. I guess the fanciest part is that we have kind of all of these buttons. But it's a single script, our game manager, you remember from the other day, our game manager. And our game manager has two functions that run that whole calculator. One for when you click on numbers, right? And the other for when you click on operations, right? And some of these are, it's kind of written out longhand to demonstrate some if statements, some comparisons. We have a for loop, we'll talk about in a second, and we have a switch statement here that you'll see in a second, right? But everything is really kind of driven by simple UI interaction and some simple logic. So we're going to see in use some of the things that we've been talking about, our operations such as our compound operation and assignment here. We have, just basic assignments and some basic math, right? So that will be available for you to kind of check out. And you can certainly use that as some inspiration for your project, or really just, like I said, we'll kind of roadmap how to do these sorts of interactions, how to connect these button events. And we're also going to have the other one over here is we have some fun slider and a button over here that'll allow us to show how much of an electric shock we're giving the player, something like that. Some simple fun things. All right. So probably not any questions yet. Hopefully not. And I'm going to go set that so that I can show the appropriate screen. And we're going to start off. We're going to take up sort of where we left off the other day, which was sort of, where were we? More or less here in programming part 2 over in the slideshow. Now, how does the text look on the screen? Reasonably legible? I'm hoping that it's everything is nice and reasonably sharp. Is that text is very readable? Like even in the case like this, is pretty readable? Okay, good. All right. So one of the big things we're going to discuss today, these more on conditionals and loops. We sort of introduced the if statement and if else the other day, and we're going to talk also about loops today, things like for loops, while loops, for each loops, do while loops, and so on. All right. So our go-to conditional when we want to say, well, if something happens, then something else should happen, or if some state is achieved, or if we're in some state, then we need to have some code run based on that, right? This is logic. This is the fundamentals, one of the fundamentals of program flow and execution, being able to modify what steps the computer takes according to some conditions, right? The program takes according to that, right? So if else is sort of it's the basic, most flexible conditional in C#. You can more or less do, well, we don't use go-tos. I don't even really generally, haven't been talking about them, but there are some other things, like more advanced things like case statements and switch, or case and switch, the case and switch statement, which you can also kind of do with the if statement, but this is the basic one. All right, so things like if this is true, then do some certain thing. So imagine all we had was if daylight equals true, then play the happy music because it's daylight, right? Straightforward. But you can use combinations of if statements and the various levels and the fact that we can scope things to create much more complicated or much more precise relationships. So for example here, I'm going to use an else statement. So I'm going to say if daylight equals true, do this. Else, if night equals true, play cricket sounds and owl sounds. Okay, now imagine, just consider the two of those. So what would happen is if we would come along, we would execute, and then if is daylight equals true, this code would happen, and it wouldn't bother with anything else. It wouldn't bother with anything. It wouldn't check this if down here and so on, because the first statement was met, and it actually would execute. So that would be good. If that failed, if daylight was not true, then it would go into the else piece, and it would execute this conditional. If else, if night equals true. Now you might say to yourself, well, isn't it either day or night? And you would be wrong, because in this case we've decided that there's a special condition of twilight or evening time, right? But imagine we had those two and we said, if this is true, do this. Else we check, is it night, right? Is night equals true? And if so, play the owl and cricket sound. So run if daylight was false and is night is true, right? So just from this statement here, even without explicitly creating an and in there, it will run through. Now, I could have done it as two different statements if I wanted to. I could have had if daylight equals true and everything in here, and then another if is night equals true and daylight equals false. I could have had that as its own if statement, but that would be basically checking the same thing twice. No reason to do that. So for efficiency's sake, we can do things like this, where we can have an else, where we know now if it's in this else, it means we know for sure that this did not evaluate to true. Right? Did not evaluate true. And I don't just mean it's daylight true. I mean this condition here did not evaluate to true. So it would then go on and execute here. So, like I was saying, if we had this kind of weird state, or we have this important state to the game where it's a werewolf game, and we need to know, is it dusk? Right? Is it that time of day right between daylight and night? So if we knew daylight is not true because that didn't happen, and in this case, is night did not wind up being true, so we know it's neither of those things, therefore it must be this kind of twilight, right? Run if both conditions above were false, well then it must be twilight. So we play that ominous sunset music there, right? Whatever it is, or here, other weird things on top of whatever we want to have going on. All right, so without another conditional here, we know what happened here. If both conditions are false, must be in here, right? That's the nice thing. Now, in addition to that, this sort of structure we have here, this kind of waterfall of if statements and else statements, we can create compound if statements by embedding them inside of one another. So, for example, we have the scope here where once this is met, we run this code. We always play the ominous sunset music, but we have another check for another condition. If is full moon, which is only once a month, right? Something like that. Then, right, this is basically, this if is nested inside of this else statement here, which basically means it evaluates to if both other conditions were false and is full moon is true. Right? Because it can only get in here when this is true and these were false, right? So if both other conditions were false and is full moon equals true, then we can hear that werewolf howling, because this is our werewolf game, so it's dusk and there's a full moon. All right, so here's a good combination of if statements and else statements here. Now, as you can imagine, this might get kind of messy. Especially if the thing that you're checking, maybe it's the time, or maybe it's, you have some counter that you're always checking against, and you're checking it against a whole bunch of different conditions, or, some value is passed to a function, and you're always checking that one value against, is it 5, is it 4, is it 3, is it 2, is it 1, right? That might get tedious writing an if statement, or an if statement for each one of those. So we don't have to do that. We can use a structure called a switch case statement, right? Which is an alternative to several if statements, comparing for equality, right? So we have, imagine we're going to switch the number that we want to consider here. We want to consider num, and maybe this was passed into a function, and this is, kind of a weird contrived case in that it's set to just 3, and so we know where it's going to wind up. But then we wind up with a case, right? Case number colon to say this is the code here that we want to execute when that number is 0, or when that number is 1, do this. When that number is 3, we're encountering a vampire, right? When it's 4, well, we do this. Now that is a typo. Whoops, I'm going to go back. That should not say 3 or 4. That should say only 4. Oh. Okay, back to there. All right. So you can imagine, say we were trying to process, we encountered some monster, and the monster had a type variable, which was just an integer. And we wanted to figure out, we want to take the appropriate action. So what we want to do is say, all right, if it was 0, that means it's a mummy. If it's 1, that means it's a werewolf. If it's 3, it's a vampire. If it's 4, it's a zombie, and so on. Right? So we could switch the type of monster, and then take the appropriate action, that sort of thing. You'll notice in here, it gets a little bit more interesting in that we have, well, there's this break here. Break tells us that we have ended a particular case. And sometimes you can even not have a break statement if you have cases that are treated the same, right? So what happens if you leave out the break? If the case has no body, like it does in this case, this 5, 6, execution will fall through to the next case, right? So 5 and 6 have both have the same outcome. But if you try to put code in between here without a break statement in C#, you'll get an error, a compiler error. In some other languages, you can put parts of routines in here, or in good old C, you used to be able to do that. But these days in C#, that is not recommended, not the case, not what we want to do. Right? So each case statement has to end with a break, unless it's sort of an empty one, which is just falling through like this one. All right. So great for checking multiple conditions. Right. So let's see. Let's look at our example and see when we might do something like that. Okay. Now, over here, we have lots of keys that we could potentially press. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0. And then we have, so those are our numbers, and we have our operators. So we have the things that would define the operands, and our operators are our multiply, subtraction, addition, and assignment, or equals in this case, right? So, as you can imagine, there may be logic that is repetitive, and we might want to use some different things. So let's take a quick look over here in our code. And there are two functions. One for when you press a number, right? So number is pretty simple. Not entirely simple, but you can imagine normally if you press a number and then you press another number and you press another number and you press another number, right? You wind up, like say you press 1, then you want to do an assignment. We want to hold that number as our first operand, right? So we have A, which we've set aside part of our class here, we have our operand variables, A and B, and they're both integers. We're only doing integer math here. I'll leave this as an exercise for you to try if you want to change this to floating point. It's certainly not too bad. You can certainly give that a try. So we have an operand A and operand B. And when we type a number, all we have to do is say, well, whatever the existing value is, we multiply it by 10. So it starts off being 0. So if we press 1, for example, it says, well, it starts off being 0, so we have 0 times 10 is 0, plus the value that we pressed. So it's 1. If we press 1 again, it will say, okay, coming through here, okay, we take our original value, which was 1, we multiply it by 10, so it becomes 10, and then we add 1 to it, so it becomes 11. Right? If we put a 0, it would have been 1 times 10 plus 0, and it would have been 10. So that is the value that we take on for A. Now there's a special case where we're like, well, wait, I am still confused. What does that mean? A times 10 plus value. Now I'll try to clarify this a tiny bit. I'll put some additional parentheses around here. Okay. So val here is the number that we're pressing, right? So say I press the number 1, the number 2, the number 3, whichever number, 0 through 9, excuse me, 0 through 9. So based on that, I want to change the number that it's already holding, right? So we'll go, let's see, I'll save this just in case. I'm going to come over here and I'll hit play. So the initial value of A is 0. Starts off at 0. Okay? Let's take that. We know it starts off at 0. So the moment I press the number 2, remember our formula here. I'll put it over here. Well, it's going to be tough to see both at the same time. But our formula is A times 10 plus val. So val is whatever number I press. So if I press 3, A is already 0. So 0 times 10 is 0 plus val is 3. 3. Now A is 3. So A, we have it in there. We've saved it. A is equal to that value. So if I press another number, I'm going to multiply this number times 10 and add the new number. Right? 3 times 10 plus 2, 32. I'm going to add another number. Right? 32 times 10 plus 9, 329. Okay? Really easy way to handle multiple, right? Where is each button's val declared? Hold on, we'll get there. Okay. So somehow, as some people over in the chat are asking, is that, well, how are we connecting these buttons? How do these buttons talk to that script? And that's where we're going to be heading. Okay, so that's the first thing, right? So we can, as long as we keep adding here, and there are finite limits to what we can hold because we're integers here. You can't hold infinite numbers. That's why it's getting a little bit weird. We can only hold up to, what, 32 million or billion? No, million, yeah. There are limitations. We can't go beyond. So in our case, oh yeah, I can't quite get back to 0. I'd have to do this. Ready? Minus 1, 3, 6, 8, 2, 1, 9, 6, 4, 8. Whoops. Oh, I missed a 3 there. All right. Minus 3, 0, 0, 0, 0, 3, 3, 0. We're back to 0. All right. Wonky calculator. Doesn't have a clear button. Imagine it had a clear button. We should do that. All right. That'll be our goal, to add a clear button. All right. So first off, let's just look at that code. We have this code that says, all right, as long as we keep pressing buttons, this is what happens. We multiply the existing number and we add the new value to it. And somehow, on my click, happens every time we press one of these buttons, and it passes us that appropriate value. All right. So how that happens is we somehow have to tell the Unity UI, these buttons, where that function lives. Okay? So a UI button like any of these, let's look at the 0 button. Okay, here's the 0 button. So if we add a button, I'll even add a new button. So here we go. Unity, we're gonna look for UI, and we're gonna be working with Text Mesh Pro buttons now. You can use Legacy, the old ones, but we're gonna use any object from here for our project, right? So you can use images, you can text, raw images, panels. Now these are images only within the heads-up display, not actually in the game world. You're not gonna have a player image. You're not gonna have things running around the screen. These are just images on the heads-up display. And then toggle sliders, scroll bars, and so on, right? So we're gonna add button, right? So here's a new button. All right, button down here. And when I press this button, I want to have something type up here. So let's do the following. Let's say, you know what? We need a clear button. So the first thing let's do is let's make this say clear. All right. Now, give me a second here to. All right. So I want this button to clear my calculator. So I click on the button, and I want to change the text. Well, let's change the name first. We'll change the name of this game object to clear. Okay. Notice it didn't change the text on the button. It only changed the name of the game object. And the way that a button works is a button has a special graphic in an interface and things that it needs to do in order to be clicked on. But it also has a child object, which is the real text here, this Text Mesh Pro. And that's where this button is. So you'll notice in order to change the text on a button, I have to actually change the text of the child object. And we're going to, right here, just put C. Right? Classic button. Now, I might want to change the size of this a little bit, so I'm going to come over here and I'm going to look at, I have my two choices, the rect tool or the scale tool. Now, if I choose the scale tool, I can change the size of the button, but you'll notice my text is also changing, which I don't want to do. So I'm going to use the rect tool and just change the rectangle. And then I'm going to go back and use the move tool, and I'll just put this, I don't know, right there. I don't know. It seems like a good place to put it. Now, if I wanted to, I could also do things like, well, let's change the color here. So now we're changing the color of that button. Great. It's all fairly arbitrary, but there it is. We have a button. It is the clear button. It has a C on it. Wonderful. But it doesn't do anything. All right. So let's go over to our script, and for our first game, we're going to be doing really everything inside the game manager. So let's go ahead, open up the game manager script, and in this case, the C button is sort of special. It's not really an operand or an operator. So let's write a special method. Make some room in here. We're going to write a special method that we want to call, that we want to have triggered by that button click event. So we are not going to return any value from this function. So we call it a void. That means it does not return a value, void. And we do want it to be seen by the Unity system. So we're going to call it public as well. So public void, and we're going to call it clear calc. Okay, so we now have a function called clear calc. So what should clear calc do? Well, it's going to do the following. We had our variable A. We had a variable B. We're going to set those to 0. All right. So A equals B equals 0. That's the same thing as saying A equals 0, B equals 0. We could just be, I was being clever, so I shouldn't be clever like that. So clear operands. And then we also need to potentially clear operator. Now, the operator, we're going to sidetrack here. The operator is a bit of a special case. The operator can only be one of a certain number of values here. It can be plus, minus, division, multiplication, or the equals, or nothing has been pressed yet, this empty case. And I'm using something called an enumerator to do this, to kind of set up that there are these particular values that my operator is going to have to be one of these things. And if I hover over them, you'll see that I can refer to them by their numbers here. Like, so my op.empty is 0, plus is 1, minus is 2, div is 3, and so on. So it's a nice way to set up sort of constants that I can then refer to that stand for certain things, and it will automatically assign them some values for me. So that's what's going on here. I'm creating a public enumeration that is called myop, and this becomes a type. That's why it's capitalized here. It's not a variable. It is a type that I'm creating. It's not a struct or a class, but it is another sort of type here. And then I declare a variable of the type of that enumerator, right? So this is one additional thing. We should tack this on to your classes and structs. Here's another type that we can create, but a much more specialized one. So I have this variable called operation, which is initially set, when it's set up here inside the class for the first time, it's set to be empty. So I'm going to copy this because I'm lazy and say, well, that's the thing that should happen to clear the operator. That means there is no operator yet. All right, so this will clear out the operator. And let's see, one more thing I'm going to do. The other thing that happens, there's text on the screen. There's text on the screen. So let's talk about for just a moment how to access, this is an important thing, how to access things from components and fields from one game object's components through a script. Bit of an advanced topic, but it's not as crazy as it sounds. We've been talking about game objects and components for a while now, so hopefully this sort of makes sense. All right. So within my game, I have my scene. And within the scene, there are all the game objects. There's everything that belongs to the game object class in general, right? All of these are objects in here, whether they're children and so on, right? What is the game object.find? Now, remember your capitalization in there. That's why this is what's about to be important here, right? So we have a class called game object. All of these things in here are instances of game objects, right? They are actual instances of game objects. So they all have that in common, that they all are from the game object class, right? Now there are some functions that we have available that are class functions, right? At that level, they are statically defined for everyone in the class, right? So anything in this class game object can use these certain functions. Capital G, that's why it's capital G here, right? Base class for all entities in Unity scenes. And I can use find to ask for any game object in the scene or any active game object that has this name. You can see it in quotes here. So game object.find messages will look through this whole structure, look through all of the objects of this class type. Try to find one called messages, which is this one down here, which is a Text Mesh Pro. It has a Text Mesh Pro component on it, right? If we look at it, here it is. Here's messages, and the important things, you know, it's a game object like any other one. And it has certain things, and I created it just by clicking in here or clicking in the hierarchy and said, yes, give me a, say, Text Mesh Pro. There it is, right? Nothing all that fancy about it. It's just another Text Mesh Pro object, and we'll call this one, I don't know, simple message, right? You can have a name, and I could ask for this one using that find if I wanted to put things here instead of there. Maybe we'll do that, okay? So we'll watch this. Ready? Here it is. I'm going to make it a little bit bigger here. Oh, I shouldn't have done that. Let's see. Undo, undo. Undo. There we go. Okay. So back here, not scale there. Let's make this bigger. All right. Oh, I did the exact same thing again. Why is it doing that to me? Simple message. I think that's just going to work, hopefully. Why am I making new text inside of clear? Inside the clear? I'm not. I am not making new text inside of clear. Right now I'm just making a new text object here. This is just another text object just so I can demonstrate. Okay? Because I want to have text here or here or here or here, right? I've got a bunch of different things. Okay? Different possible places to put text. This one is called simple message. This one is called messages. This one is called, where is it called? I think it's reaction. I thought it was. There it is, reaction, right? So we have three text fields, one called reaction, one called messages, one called simple message. There's three of them. Okay. So let's go back now quickly and we'll say, all right, well, we have those three. We want to be able to refer to one of them. We want to be able to write text in them, right? Because the text we have that we want to give back to the player, we want that to appear within the UI, not within the console, not within wherever. So I'm using this GameObject.find messages, or maybe I have simple message. right? So this one will look for the simple message object, right? So every time you see a period here, it's saying, okay, in this case, we're going to start with the class, and now look for a member of that class, which could be a method, it could be an attribute, property, and so on. One of those things. And this is going to be a member function called find of that class. And that we pass the name, and we get a result back from that, right? We could stop right there. That is going to have a result. That is going to be, watch this, game object box to write in. We'll call it that. Okay. Game object box to write in equals, and it will give me the new game object that has the box to write in. Now it's complaining because, probably because what's going on in here. So now I have what we call a reference to this game object that's in the scene, right? So we have a reference to this game object because we asked the system for it. Once we have that reference, now we can decide to look for components that belong to that game object. So this simple message here, it has these components. One of them being a Text Mesh Pro component that happens to have a text field, right? So this is how we would find that. We would say, okay, box to write in our game object. We would ask for a component belonging to that object. Now, if you remember our brackets, when we talked about the different types of brackets, braces, carets, and so on, these angled brackets, these are used when we have generic functions and we want to pass a type to the generic function. So we're saying, okay, we want to get components of this type in here, right? So we say get component text mesh pro u GUI, which sounds awfully specific because it is. All right, this is the component, the text mesh pro component that lets us put text in the UI. Now, if you're just typing following this, you may note that it's going to barf on this. It's saying, no, it's not recognized. It doesn't know what the heck you're talking about. And that's because you're running into something called namespaces. Okay. Now, in Unity, C#, when we created a class, it gave us this system collections. You said using system collections, generic, using Unity engine. And if I hover over them, you'll see it says namespace Unity engine, namespace system generic, and so on, right? And this is basically telling the system, like, oh yeah, those are the things, this is the include files, these are the prototypes, these are the functions, these are the type definitions, and so on, that I'm going to be using inside of here. And it kind of clues the compiler in on all the things that I might want to do. And by default, it doesn't know about the Unity UI and all the types that belong to it. And it doesn't know about Text Mesh Pro and the things that belong to it. So we're adding here this using, it's unnecessary. That's interesting. I'm not sure, how am I supposed to do that? That's used to be how I did it. Let's see. Quick actions and refactorings. Remove unnecessary usings. So what's it going to do? All right. I guess that is good enough. We could say apply that. All right. Simplify things. Using Unity Engine, using TM Pro. So welcome to Unity 2021. Let's see if it's still, yeah, all my text looks good. It's not complaining about anything. So, all right. So if I hover over here, it's saying, all right, as long as I have the Unity Engine namespace and as long as I have the Text Mesh Pro namespace, life is going to be good. All right, good. We'll keep those two. And because of that, now down here in our clear function, it should be okay with us using Text Mesh Pro GUI. Yep, still is. All right. So this part here is now saying, let's get the component of this type, and we have to do this because it's actually calling a function. Now, if I wanted, I can go one step further and say, well, I'm asking for a component of that type, so I could even say text mesh pro UGUI call it text thing equals what we'll call it my TM Pro. That's even better. So this is going to be an object of this type, this text mesh pro, that I'm asking for here, and then I could go and say, well, my TM Pro dot text equals so and so. All right, so let's look at this. This is getting fancy, not really fancy, but maybe it'll help understand the hierarchy that we've got here. Right, it's a bit of a hierarchy. We have a game object that is going to be held by this reference, box to write in. We have to get a reference to that game object. The game object that we're referencing is really this one, the simple message, which is the one that we have just created over here, simple message. So game object, box to write in, that's a reference to this game object. Once we have that game object, we can ask for its components. We can ask for references to the components of that game object, and that's this next line here. Now we happen to know the component we're interested in is this, especially this text mesh pro UGUI component. We give it a name, and it just becomes a variable, a reference variable to this thing, right? To the text mesh pro GUI component belonging to that object, right? And then finally we can say, well, of that component, we want to change the text attribute or the text property. Notice there's a get and a set, right? So we're inside here, it's using a get function and a set function to set that property. And in our case, we're going to set the property to blank, to nothing. So fun sidetrack, fun side comment, but that explains sort of the whole hierarchy of getting a property of a component of an object, right? Good thing to know. So we have the function we want to call, but we still aren't calling it. We still haven't hooked it up, and maybe just to make it more obvious, let's put this in. We're going to say print you pressed the clear button. Let's do that. Okay. And save it. So in order to hook this up now, this clear calc function to the clear button, now we're going to look at how Unity and C# integrate with one another. So we come over here. There's our button that we want to attach, right? There's the clear button. We click on the button, not on the text. If there's text that belongs to it, right? We want the button. And you'll notice over here in the properties of that button component, there is this field in here called onClick, and it's a list of things that should happen when that button is clicked. And I want to add something to that list. So I come over here, I press play, press plus. And now I need to tell this object, or this component of this object, about a member function of a component on another object. We're going to do it the Unity way now. All right. So the most Unity UI way to do that is to say, well, it's the game manager. So important life hack, life tip. I'm going to use this little lock button up here. I'm going to click the lock button, which means don't change which object I'm referring to over here when I click over here. So I can click anything if I want. But I'm interested in the game manager, and I'm going to say drag the game manager over to this box here. And that says, okay. When it said none object, that means that there is no game object yet assigned. It's not referring to any game object. Now it's referring to the game manager game object. So if it says none, that means there is no game object. It's not yet referring to any function or any component of that game object, which is why it says no function. So the next thing we need to do now that we have a game object that we're using, we click on the drop down, and you'll see for that game object, we can see things that belong to that game object. In our case, the game manager has our game manager script, the component that we wrote, and we can see some of these are built in, part of the MonoBehavior class, but the other ones that we have created, like here's ClearCalc, here's that function, that member function that we created, that now we're going to select that, and you'll see, okay, the game manager object, the game manager component, the member function called ClearCalc. That's what's going to get invoked, that's what's going to get called when onClick happens. All right, so if I press play, and I come over here, and I press the clear button. Right? I press the clear button. And new text, which was down here, got cleared. Now up here is where these other things are appearing, but if I press clear, I'm clearing the text down there. So maybe, now, okay, well, the sound effect is happening because the sound effects is just part of the system. There's a cartoon, there's a sound object in here, we'll disable it. There's just another game object that happens to have an audio source. Now let's unlock this here, that'll be helpful. You'll notice this cartoon game object has an audio source on it that we dragged in the other day when we were first kind of playing around with the UI. So we'll just disable that if we want, so we won't hear it. It doesn't know, it's not an automatic thing. I just had it there so I would know that it was running. It was kind of a cool thing. Optional. So, but now we have functionality associated. Oh my gosh, did I do all that in play mode? Did I do that? Oh no, I disabled the clear button. That freaked me out. I got nervous there. I was like, oh my gosh, how could I possibly have done that in play mode? But no, I just, before I turned that off, I had cleared my, or disabled my button. You can disable different things in your scene by disabling them up here. So, last but not least, what I want to do is say, well, I'm not really interested in this thing getting cleared. I'm interested in this thing getting cleared, right? So it'd be nice if I had some way of telling this function here, this component here, which thing should get cleared. This one, or this one, or this one, whichever one. All right. So one of the things that's happening in the game manager, if I click on the game manager over here, I'm going to see all of the public fields of the game manager. And you'll see right now there's operation, which is empty. There's X and a Y, which we used last time. There's this reaction text box, and there's the game manager. So we double click on that. And instead of looking for simple message or whatever, we might want to be able to assign that from the Unity UI. So in order to do that, we want to expose that reference to the Unity editor. And when we want to expose something to the Unity editor, we have two choices. We either make it a public variable like we did here. There's a public game object reaction text box, which is showing up there. You see that? Reaction text box. Or we have the option of saying that is a serialized field, which is a game object calc text. We'll have calc text there, right? So we have this game object called calc text. That's where we want to put the text. So I'm going to save it, and Unity will, in the background, is it going to do it? Looks like it's getting ready. I'm going to come back to it. There we go. There's calc text that's ready to receive a value, but it has nothing in it just yet. Okay, so let's use calc text here instead of simple message. Now, I'm not going to put calc text here, right? That's not the solution. Calc text is a reference to specifically already a game object, right? All right. There we go. So instead of asking the system for this to figure this out, instead I'm just going to say calc text. And that is a game object that I can then refer to. Right? So I have a reference. So you can create a game object on Unity using VS Code. No. Well, you can, but not. This is not how you do it. This is a reference to a game object, not creating a game object. Important distinction. We're just referring to a game object that's in the scene. Because right now, if you watch, okay, I've declared this as a game object. Now if I come over here and I save that, and I just come to Unity, and I press play, you're going to see something wonderful happen. Now you certainly can. There are other ways to do it, but not like this. So have press play, and I'm going to press clear. You'll see I've got not just a warning, but an error. Right? It says, unassigned reference exception. The variable calc text of game manager has not been assigned. I probably need to assign calc text variable of the game manager script in the inspector. Right? Because I didn't create an object. I just created a reference to one, and I didn't tell it what that is. To actually fill that in, I need to come over here and say, well, what's supposed to happen is this messages box. That is what I'm referring to when I say calc text, right? This is the message box. So once I establish that, once I have that reference in there, then everything will work, right? So I'm not creating a game object, I'm just referencing it, right? And now everything works. And I can press clear. And I'm back to the drawing board. Okay. So, important thing from there, and then we'll go back and we'll go back and forth a little bit. The idea of having this button, which a part of that button is this on-click event that it can call or it can raise, this event. And when that event is raised, it says, okay, go to this game object, go to this component of that game object, and call this member function of that component of that game object, right? In this case, it was the simplest case because that component or that member function doesn't take any parameters and it doesn't return any value, right? So it's just a simple thing. It just says execute it, do everything that's in here, done. Okay, so that's a little jaunt. We know now how to connect that button to this function. Okay, now one of the main things we noticed before is that we were actually passing values, and we'll talk about that in just a minute. All right, so let's go back over here, and my pace is all out of whack, but we'll get there. While and do while loops. So let's talk about while and do while loops. And sometimes it's important to be able to do things repetitively. Computers are good at that. So we have loops. So the idea behind while and do while loops is so that you execute the body of the loop repeatedly so long as some condition contained by the while part is true. While loops will check that condition first. Do while loops check the condition last. In other words, they will run through the loop body at least once if it's a do while loop. If it's a while loop, it may skip over the loop entirely. Okay, so we have while and then the condition to execute. So in our example here, if we set a Boolean called is alive, we set it to true. If something is true, then it's going to execute in here. So, okay, well, this code comes through. It starts off bool is alive true. Health is set to 10. There should be a semicolon at the end of this. I don't know how I skipped that one. Okay, but anyway, while is alive. So this, we're going to get into this loop. We're going to start executing. And the first thing it does once it gets in there, it says, okay, I'm going to check health. But before I even check health, I'm going to decrement it. So I'm going to subtract 1 from my health points. So for some reason, I'm in here, I must be in a poison cloud or something like that. So as long as I'm in this loop and I'm still alive, I'm losing health. It's a really weird, contrived loop. It's not really all that useful, but that's the idea. So as long as it's in this loop, it's losing health, and the moment its health becomes 0 or less than 0, it's becomes 0 first because it's got to become 0 before it becomes less than 0. The moment that happens, is alive is going to get set to false. So once we run out of health, we're no longer alive. So that executes, and the next time through, it's going to say, oh, 0. Well, if it didn't happen, if we weren't dead yet, if we're still alive, it'd say healthy is health. But it would come around here and say, oh, is alive is false, and it wouldn't do the loop again, right? Because is alive has been set to false in here. So normally, your conditions here are something that is going to be calculated inside the loop or set inside the loop. You have to be careful with a do while loop. While loops tend to be the ones that wind up being sort of infinite loops. Someone accidentally does something, you set some sort of condition that's never met, and then you wind up with these weird infinite loops and your system blows up on you. So be careful with while and do while loops, because you have to make sure you write your conditions appropriately and that your condition will eventually break out. Right? So here's the while loop. Now a do while loop. There's no such thing as just a do loop. You always have a do while loop. The do while here always is going to get executed at least once. So we fall through here. Health is 0. We start in here. So the first time in, health is less than or equal to 0. So we're going to print you are a zombie the first time in. And then skip all these because it met that condition. After it does that, though, it adds 1 to health because this is the health increment. And it checks while not is alive. And, well, we're not quite alive yet. We're still in that, if this were Dungeons and Dragons, this should be like, we're rolling our death saves or something. Or wait until we roll 3 is alive death saves, death saving throws. So to go through here, next time up, it's not going to print you are a zombie because health is no longer less than 0. Or less than or equal to 0. Instead, it's going to come in here and say, well, okay, health is less than 10, and it would print you are recovering health. Do that. Not quite 10 times, but I think it would be 9 times, right? But then the last time, once you have health that is not less than 0 and not less than 10, we know is alive is true, and therefore we get that bonus health point here at the end, and we can pop out of loop because is alive is now true. We're not is alive anymore. All right. Whew. So that's while loops, do while loops. For loops are another type of loop. You can create while loops using for loops as well. For loops have sort of even more control, and generally the consideration is that they're the condition, the initialization condition and iteration parameters or programming of that loop is contained within this for. Now you can violate this, but for starters now, this is generally how we want to see for loops, all right? They're usually used for repeating a specific number of times, and the simplest versions are always like this. For int I equals 0, I less than 10, I plus plus. That means run this loop basically 10 times from 0 through 9, right? The moment this condition is no longer true, you no longer execute the loop. Right, so first time in, it sets this. The first part only gets run once, the initialization of the loop. And then on each iteration of the loop, it checks this condition. And if that condition is true, it continues through. And once it does an iteration, then it adds, in this case, does whatever is the iteration part. Right? You can do things similar to a while loop, but it's more self-contained in that regard. So a while loop might be something like this. You might substitute, instead of a while is dead loop, you could put a for with no initialization, but the condition is just is dead. So as long as is dead, loop on through. So you can actually do that. All right. As another special case, sort of like a for loop, but it's used when we have collections of things. We haven't talked about collections yet, but we will in the future. A collection is when you have more than one thing of a certain type. Imagine I have a class full of students, right? That'd be a collection of students, and I wanted to go through each student, checking to see, is everyone present, so I can put them in, give them attendance credit for that. So I would say, all right, give me a list of all the students in the class, and then I would use a for each student, for each loop, to iterate through all of the students within the collection, within the class, right? So this example, we use the list collection, and it's a collection of strings called player names. Could have student names here. And then I would say for each, I have a little temporary here that I'm using so I can kind of iterate through and process each one independently, so I can refer to them each time through the loop. I'm going to get the next one in the list there. Question: what if you do a for each loop, but instead of a new variable, you use a pre-existing variable? So instead of pname, you wouldn't do that because you wouldn't be able to iterate over it, because you want to refer to each of them in the collection. This is how we refer to, this is the thing that we will iterate through the collection, right? You can refer to member, like if this is an actual, not just a simple string, if it had other values in there, you could refer to, like if you had social security number, RIN, RCS ID, all parts of a player object, and this list was a list of player objects, I could look at the individual things inside of there, right? But in general, yeah, that's not how you would use a for each loop, if I'm understanding correctly. What if you do a for each loop, but instead of a new variable, you use pre-existing variable? No, this is specifically saying how I am going to refer to each of these in this collection, right? If I don't use this, I'm not going to see the members of the collection, and that would defeat the purpose of using the for each loop, right? So that's why I would do that. Okay. Now, so we introduced loops. Let's see a loop in action, right? Before we talk about interrupting a loop and getting complicated, we'll see a loop in action. Now, this code in here, let's see. We have our calculator, and if, as most of you know, hopefully all of you know, multiplication is an awful lot like in a loop. We can do, basically we're saying how many times to add something to itself, right? So if I said 9 times 3, it means I want to go through and add 9 3 times. So I could do that with a loop. I'd say run a loop 3 times, adding 9 each time. Press play, and we'll say 9 times 9, and we get 81, right? Because that is 9 81 times. Now, that's a bug. It shouldn't say that. Why does it say that? Oh, I know why, because that's the result showing there. Oh, that's a bug. That should have been showing the operand, which in this case has already been switched. So it's got a bug in there, but the calculation is correct. But we have a bit of a bug in the display. Times 2. Yeah, that's a bug. All right. Now, obviously we have multiplication. We could have used multiplication. We probably should have used multiplication, but to demonstrate, I wanted to do things as a for loop. There we go. Excuse me. So, looking at this code a little bit more, let's talk about how it uses if statements and switch statements, and is a little bit more complicated. Now, we'll also look at how it connected to the other one. So, on my click is when numbers get added, and it's either adding to the first operand or the second operand. And it knows which of them, basically, if it sees that you have pressed an operation, it assumes that the number that you are now entering is the second operand. If you haven't pressed an operation yet, you're changing the first operand, right? That's the idea between these two. Okay? So the first time around, if you haven't pressed an operation yet, that's why it just says the text, show the number that you've entered so far, right? Just put that on there. Next time, otherwise, it actually appends the number to the end of the text. Like the calculation here is similar, but it appends your text to that text, your string value to the end. By appends, I mean it puts it at the end of it. Okay? So that part is pretty simple, right? This part, you're either adding one or adding the other. The operation is a bit more complex because we have multiple types of operations to do. You'll see what I've done here is I said, all right, well, the first thing, as I said, well, if we're pressing equals, this is what's happening. Now, somehow we're passing in a number which represents the operation we want to do. And that operation is going to be 0, 1, 2, 3, 4, 5. Right? One of those values. It just so happens that 5 corresponds to equals. And so the first thing I'm checking here is I'm saying, well, okay, if we passed in a value and I want to compare it to this 5, and there's a little bit of magic going on here saying, all right, I know I passed you an integer, but I want you to consider that it was one of these 5 types. It can only be one of these things, which is why I use this, I put this little my op in front of it. I'm doing what's called a cast here to say, yes, I know it should be one of these 5 types, so this comparison is legitimate. Okay, so it says if val, which could be one of these 5 things, is equal to 5, which is the equals, well, then that means perform the operation. And we have operation held in a variable, so we know what operation we want to do. So we can check, okay, is the operation that we want to do, is it a add, in which case we wind up doing this part back here. It gets printed to the screen, but it's this add, A plus equals B, piece of cake. If the operation that we queued up is a minus operation, well, yeah, it's a minus equals B, easy enough. If it's multiplication, we do it the hard way, and we have a little loop in here. We have a little for loop. So just for sake of argument, I want to add something to 0 some number of times. That's our addition, or our multiplication. So I want to take the first operand and add it to 0 the second operand number of times. So I set a temporary, or we might call this an accumulator. It's not just a fancy term. It's something that's going to accumulate some result, right? It's just an integer, but it's just a little temporary variable. Starts off at 0, and then each time through the loop, until it gets to the number that we want to do, it will add the amount to that. So the first time through, say this was 3 times 10. I'll go back to your question in just a second. All right, so we want to do 3 times 10. So A comes in here being 3, and B comes in here being 10. So that means iterate through this loop 10 times, adding 3 to 0 10 times. And then when we're done, we set A equal to that result, and we write that to the message box. Okay, so that's a simple use of a loop to do multiplication. Now, Sarvesh's question about what is in value. Now, this is always, whenever I want to connect something to, like these are operations here, on my click, on operation. These are button clicks. These are methods that I've defined, just like our clear calc method, that I want to be called in response to a action, a UI action, right? So I've got these numbers. Int val, that's going to be passed a number between 0 and 9, because this is on my click, these are the numbers. And then here, int val is one of 5 things. 0, 1, 2, 3, 4, 5, one of 6 things, sorry. 0, 1, 2, 3, 4, 5. 0 being empty, so I'm actually not ever passing it 0. But it might be 1 for add, 2 for subtract, 3 for multiply, 4 for divide, and 5 for equals. Right, so this has to come from somewhere, and then I can do my comparisons, right? So I'm going to pass in this value, and then I'm going to do the comparisons. Now, where does it come from? All right, so now let's consider again our Unity UI. So we'll go back over here, and we have these buttons, right? All these buttons, which are ultimately the numbers, and you'll see them up here. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So choose any of them. There's 9. Now, just like our clear button, there's a button component, And I've already defined here a behavior for our onClick. So onClick is going to call, we know that the method being called is part of this. It's a method that is in a component of the game manager, right? All our script is in the game manager, so that's already set up. We did that by just drag and drop sort of thing. And then the function we want to call, or the method we want to call, is from this drop-down list. And you'll see onMyClick is one possibility, onOperation is another possibility, shock the player is another possibility, and clearCalc. These are all the functions that we created, plus some other things that are part of the Unity mono behavior. But we're interested in onMyClick. And notice it says int, right? Because I have defined that function, that method, as taking an integer argument, Unity sees that and says, okay, I will let you pass an integer to that method, right? Now, what integer should you pass? Well, I get to define it right here, right? So I can say, in this case, button 9 is going to pass the number 9 to that method. If I click on 8, or 1, you'll see everything else is the same, but I use number 1. And number 3, 3. Right? 4, oh, well, that's a bug. I never did anything by 4. So that should have been 4. 5 has 5. 6 has 3. What? All right. I must have edited something in edit mode or something. 8, 9. They're all good now, the rest of them. So that's how the numbers are handled. They're all using this onMyClick. The operations, if I click on one of those, you'll see, all right, they're similar. Let's make sure we choose a button, right? But it's not onMyClick, it is onOperation. Still referring to the game manager script. So the game manager component on the game manager object, but calling the onOperation method here, being passing in an integer. So I can look here, if we look at the multiplication, for example, and where is it up here? Times, we called it times there, I don't know why. Times is passing in the number 4. And where are the other ones? Minus is passing in the number 2. Plus is passing in the number 1. Where do those come from? Well, those are special, right? Those numbers correspond to when I set up that enumeration, right? Here's where we defined what those numbers would be, right? So I set up a list here. So empty is 0, plus is 1, minus is 2, mult is 4, equals is 5, div is 3. We never use that one, right? So this is where I go to figure out, okay, what number do I want to pass in? So I have a way of having that defined. Do I have to use an enumeration there? No, I could just have in my head, part of my design said, yeah, I'm always going to use the number 4 to be multiplication, but it's nice to use an enumerated type or enumeration for that so that I can refer to it in here, not just as a magic number, but as, I know that as my op mult and my op minus, my op plus, right? So I'm being a little bit more explicit in terms of what's going on, right? Now, to demonstrate our switch statement, you remember our switch statement. We have an example of it here. So you could say value is 3 by saying my op value makes it into whatever the third, not necessarily by default, it's not by position. In this case, I haven't modified these, but I could do this if I wanted to. You can set them to be whatever you want and it will continue there. So I could make them anything. gets potentially a little weird because it's going to say 6, 7, 8, 9. So be careful. I don't know if it's going to... I'd love it through a compiler error at that point, but it's not just the order they appear in, but when you don't set the value, it just so happens that it will correspond to that 0, 1, 2, 3, 4. You know, start numbering them at 0. If I wanted them to start the number at 9, they'd be 9, 10, 11, 12, 13, 14, be whatever you want, but okay. The important thing is this is a nice way to have hopefully distinct and unique values that we can compare to, right? That's the purpose of, one of the purposes of using an enumeration like this, all right? So now we've dispelled the, dispelled the mystery of where this comes from. It is passed by that Unity object on that event according to whatever it is that we set, right? So that seems all well and good, right? And hopefully that makes sense. But let's look at some other ones, some other objects you might want to deal with. Like, for example, here's another button. And you'll notice I press this button over here, and it's sort of acts as you'd kind of expect based on these. It shocked the player, and I'm going to pass a value of 1,000, or it seems to say 1,000 there. But notice I also have this slider here, and I'm going to move the slider, and you'll see, you know, the value of the slider is being sent. And this value to 1,000 is being sent. So let's look at, in the Unity UI, how is that happening? So if I click on the slider, still on the canvas, let's find that slider here. There we go. There's the slider, which has a bunch of things on here. But we'll look at just the slider specifically. You'll see it has, instead of our on click, right? Because it doesn't activate automatically the moment you click on it. It activates the moment you start moving things on it. So we have an on value changed. And we're still referring to the game manager. And we have a function, a method inside the game manager called shock the player. But you'll notice something a little bit different here. We have, down in here, we have shock the player, which takes a float. We also have shock the player, which takes no value whatsoever. And you don't see a value here like we saw in these other ones, right? Where equals, for example, we had a value that we set here. So instead, you see up at the top here, there's something called a dynamic float. So certain types of controls will have dynamically available values that we can send to functions. So if we've defined a method, a function that takes a floating point value, we can assign that to the dynamic float version, as opposed to, if we did it down here, it would be asking us what number do we want to type in there. We don't want that. We want to have the dynamic version. So shock the player, that's what we want over there. So as we move that up and down, it will be that value. And the other one over here, I put this in because, where are we? Shock. It is just calling shock the player without any value whatsoever, right? So it's just a void. So let's take a look over at our script to see what's happening there. And this is an example of something called polymorphism. So you might want to watch for this. This is sometimes within our classes, we will have functions that are named the same thing. So we have shock the player here and shock the player here. And this one takes a floating point value, and this one takes no parameter at all. We're allowed to do this. So depending on what we need the function to do, if the function has different parameters, it is considered to be a different function or different method. It's nice because we can use them fairly interchangeably, and we know it's all about, printing out shock the player and whether or not we're passing it in a value, or this one effectively says, oh, use whatever the default value is. And now I'm calling shock the player from here, and whatever the value that we get set is set to there. Okay. Is the one on the bottom the function that takes the dynamic float? Absolutely, right? If we don't have a floating value, now this one can take a dynamic float, or it can also take a static float. It doesn't care. This function shows up in the two places, right? The slider here. So this function, shock the player float, and shock the player dynamic float, they are the same function. They refer to the same function. All right? There's no difference between the two. What's really different is that Unity is saying, well, what are we passing it? Like if I went over here and said shock the player float, it takes this number. It ignores the slider value. If I take the dynamic version, it passes the slider value. Otherwise, it uses the same function. It's the same function that's being used. Okay? So that is how we connect UI objects via predefined events that are appropriate to each of those UI objects, and we use those to trigger calls. Where is the dynamic float set? Well, the dynamic float is set by moving this slider. It's the value of the slider. Right? This slider is going to go between 0 and 1, the minimum and maximum here. So as I slide it here, you'll see it's changing. So it's the slider value that's being passed. The dynamic float is always the value that is changing for that particular control. Now, like another control that we might work with over here. Wow, my stomach is grumbling. Apologies for that. In the UI, there are also things like toggles, right? And this is going to have a state that's either on or off. And this is a really useful one. So toggle being on or off, it has a dynamic value of true or false. So when I set the slider, do you have a function attached to it that just changes the text to show the current value of the slider? Yes, that was what we had at the bottom there. Whoops. Right? Here's what it's doing. It is writing ouch and taking the value that was passed into it, and that's the value that gets converted to a string and printed as part of that message, and then assigned to the text of the reaction box. Okay. So the toggle, for example, notice it's on value changed Boolean. And if I want to add something onto that value changed, and I go to my scene, here's another way of assigning it. Make sure if you're assigning things by using the target there instead of dragging from over here, that you attach things from the scene. And if you don't see the list over here, you can adjust this over here. Definitely set it to that. Way more usable. Refer to the game manager here. So now we'll refer to things that are in the game manager object. We'll go to the game manager script, and I can pass values in here. So I could decide, well, all right, I'm going to send it a, well, I don't have any functions that take Boolean as a parameter, so it doesn't show up in dynamic bool. I could enable and disable the game object with that, but I don't want to do that, or do some things here. Don't want to do that. But I could just assign the value changing to, 5. And this will basically do the same thing now as equals would, which is silly. We wouldn't want it to do that, really. But 9 plus 9, 5 equals. So it wasn't even on my click. I meant to be on, the other one, on operation 5. So it would have been the same thing as equals. Not particularly useful, but anything that has a value change, we could have had it, change this static number here. But if I wanted to have something that really reacted to, let's see, how do you make sure a dynamic float will show up when you do the clock thing on the slider? The clock thing. What is the clock thing? I don't understand what that means. It will be called as a result of this value changing, right? The click thing. It does not have a click event on there. It only has value changed, right? So if the value changes, this function gets called, right? On value changed. That is how this works. If you wanted to have it change as a result of a click, you probably want to have a button, because it's like whenever it's changing. Now you might want to do something where during initialization you set it to change. Could you do something really crazy like add? Oh boy, no, I can't add a button to a slider because it's already there. Yeah, sliders aren't meant to change to automatically transmit the value when you click on them because it was already set to that, right? So it should already be at whatever value it was. There's no reason to invoke it based on the click. Right? So to get the toggle to really do something important or interesting, we would need to define a function, a member function of some sort that void say we wanted to turn a flashlight on or off. All right, so now I'm going to create this toggle action that's going to take a Boolean and print out the value. Come back over here. And grab our toggle. Game manager, toggle action, bool. Well, not that one because now I would set that to true or false here. Instead, I want to say game manager, dynamic bool, toggle action. So whatever that's set to. So we'll press play. And we'll watch over here in the console window because that's where we're just sneaking through here. Flashlight is true, flashlight is false, and so on. Okay. So all the ways that we need to communicate to the game the user's action, right? So as you start to fill in the conditions, as you start to design your heads-up display, we can fill in the state, right? And you probably are going to be doing that inside your game manager, right? In your game manager here, the first thing you're going to define up here right after the class is going to be like, okay, int hour, int, I don't know, could have been time of day instead of hour, whatever conditions you need to track, whatever things you need to do with regards to the game, right? Assign your variables, and then you're going to have different functions that will be there for manipulating them, deciding, if you want to move forward, right? One of the things that we're going to talk about on Tuesday, we're running out of time today, is we're probably going to use a vector2 my position and say a vector2 goal position. Right? And we want to be able to figure out, so let's see, equals, we'll initialize them, new vector2, say we'll put my position to be the center of the world, and the goal position here's the secret, this is the secret now, right? It's going to be at 5, 5. Don't tell anybody, right? That's where the goal is. So we're using vector2s for positions here, my position and the goal position. And we're going to use those buttons then to move, to change the value of my position. So we might have, say, suddenly we have a void, we'll call it public void move player x int right, and ultimately we're going to say where'd it go? My position, sorry, not my position dot x plus equals mx. Is the audio off, like off entirely, or hello? Hello? My mic is still on. Sorry, Kevin. I guess my audio is still working good. Freaked me out. Well, thankfully, we're at the very end of things. You still hear it? Okay. So we'll end on that note, and we'll start talking more specifically. And we're going to do review. So we'll review. We'll go through here. We'll finish through the slides. Now, you can certainly review through the slides. We're going to pick up with the numbers and movement with vectors next time. And there's another lecture officially where it will reiterate the things we said with regards to the components and changing theirs, and we'll also start to get into scenes and audio sources. So we will threw me totally off by having the last things going kabloom. There's a playlist. I posted the playlist on the channel. I'll post a link to that specifically in the LMS content as well, so you'll be able to find that. But there is a YouTube playlist that has all the or at least a version of each of the lectures so far. It may not be the morning or afternoon version, but they are there. I think I pinned it in the channel, in the general channel. If I didn't, I will make sure that after I upload the latest versions. So let's see, just so I haven't entirely lost my train of thought here. So imagine here that we were passing in a value and this is a little bit of syntax here. Slides are always available. Slides are available on LMS. If you haven't been looking at LMS, that's where the syllabus is. That's where all the slides are. There's definitely the Google Slides are all posted there. And there will be a link. So LMS is your friend. Look at the content areas on LMS. Okay. Right? So under here, here's everything. Right? Syllabus, feature points, introductions. And here's the 2 lectures, kind of the one we started last class and continued today, and this is when we kind of started today and we'll continue next, and we'll kind of bounce back and forth. So all the resources I just mentioned before are in here, and I will post a link to the playlist of all the lectures in there. All right. And how many do I have? 5 minutes? I do have 5 minutes, so let's just post this as a hint. Oh, that's a capital X. That's why I couldn't do that. All right, I didn't want to do that. So imagine you had your up or left and right buttons. Here's a little hint. Move player X, adding to my position X. Move player Y, add to your position Y, and you may have plus or minus 1 in there. So every time you press the appropriate button and you call the appropriate function, the player will move in the appropriate dimension, right? So we'll talk about vectors more next time. That's a little bit of hint. Okay, we'll wrap things up there, and I will post the playlist just in case you can't find it in the general channel. Pretty sure it should be there. Yep, it is there. You guys just are really chatty over there. And that should be it. Have a great weekend. I'll get you your feedback to your designs as soon as I can. Hopefully we'll be in person. Take care, everybody.